Hello everyone. In the previous session, we talked about algorithms, and today we will talk about matrices. In the previous sessions also, we talked about the set of numbers like integers, rational numbers, and so on. So you're already familiar with numbers anyway. What do we mean by vectors? We also introduced you tuples. Vectors are very similar to tuples. Like, for example, as elements of the vectors, I can define different numbers, -3, for example, +4, and so on. Here also, this is +2. And whenever this is plus, as you know, for numbers, we usually don't mention it anyway. And for negative value, we show it. So, as you can see, elements of the vectors could be, for example, numbers. They could be also strings as well. And in vectors, this is very similar to tuples, right? In tuples, instead of these brackets, we have parentheses like this. So 2, -3, and 4. So tuples was very, very similar to vectors. And whenever we talk about matrices, we don't have only one row necessarily. We could have a, for example, m to n size. Like, for example, I can define a matrix like this: 2, 3, 4, 1, something like that. So I can also put negative values for these ones, for example. So as you can see, matrices can contain more than one vector. So each one of the rows, we can consider them as vector, right? So for matrices, I can define a size based on the number of rows and number of columns. As you can see here, we have 2 number of rows and 2 number of columns. But what about arrays? Whenever we talk about arrays, what do we mean by that? Arrays, we can also define it as a set, something like this. Like, inside the array, we can have a vector. Like, for example, if I call this one v1, I can this array can contain v1 as one of the elements. This matrix, for example, I call it m1. So m1 can be an element of this array, and it could also contain numbers, like, for example, 2, 3, and so on. So again, if I want to consider all of them together, what we can understand from this is that numbers are subset of vectors, vectors are subset of matrices, and matrices are subset of arrays. What does it mean? It means that any vector you can have, you can consider it as a subset of an array. Like, for example, if I have this one only, this vector, I can also call it an array, because vector is a subset of array. The whole thing here could be just one element inside of array. And of course, it depends how we can define such things. But anyway, in general format, we could say such things that if they contain the same elements, then we can define them as subset of each other, right? Right, so here you can see the official definition of matrix. And as we explained before, it can contain number of rows and number of columns. Here in this case, again, we have m by n number of matrix. How we can calculate the summation of matrices? So to do that, we should consider exactly the position of each matrix. Let me see, where is my arrow? Yes. So example, this one, ij, again for b, it should be ij at the same position in order to make it happen. See? What does it mean? It means that, for example, if I want to add these two matrices together, then the position A, 1, 1. What does it mean? It means that the first row and column, this one should be added exactly to the same position of the second matrix. It means this one. So in order to find, for example, this summation for example, C11, if the name of the matrix here is C, then for C11, I should consider A11 and B11, and you should do it for the rest of the elements. You see, for example, for this one, 0 plus 4, it is 4. It's pretty easy, right? So for summation, you should be careful that you just add exactly the same position of elements together in order to construct the summation of matrices. And what about the multiplication? Multiplication is a little bit more complicated comparing to summation. Let me show you in one example. Like for example, for this one, what's the size of this matrix? 1, 2, 3, 4. It contains 4 number of rows. And what about number of columns? We have 3 of them. This is the size of your matrix for A. What about B? We have 3 number of rows and 2 number of columns. In order to be able to multiply 2 matrices together, we should be careful that the number of column here should be equal to the number of row. That is, you cannot multiply B to A now. So it's very important that what's the order. Not necessarily they are equal, and sometimes they cannot be even defined. So what would be the size of the multiplication now? So what do we have now? 4 rows and 2 columns. So AB, if I want to talk about its size, it should be 4 times 2. And that's what we see here. We have 4 number of rows and 2 number of columns. So how we can find the value 14 here? In order to do that, I should consider AB11. I'm looking for this one, right? It means that from the first matrix, consider the first row, and for the second matrix, consider the first column. In order to make this calculation happen, so we should know, first of all, we are looking for which element of AB. If this is, for example, 1, 1, then first row, then first column of the B. First row of the A and second column of B. So one by one, we should multiply them together and calculate the summation. That is 1 multiply 2. We should find the summation of them. 0 multiply 1, which is 0, plus 4 multiply 3. So what do we have at the end? At the end, we will have 14. Another example, like, let's say I'm looking for this one. What's the position of this one? This is the second row and second column. Again, you can consider the second row of A and second column of B. Or for example, this one. This is the fourth row of A. I should consider this one. And second column of B. So this is the procedure that we should apply in order to find the multiplication for A and B. And in this example, as you can see, the size of A and B, both of them are the same, 2 by 2 matrices. So in that case, both of them, AB and BA, can be defined. But the question is, are they equal? Not necessarily. when we find the answer, you can see that these two matrices are not equal. How can I understand two matrices are equal? I should compare them element by element from each position. So 3 is not equal to 4. As just one counterexample, I understand these two are not equal. And what do we mean by identity matrix? In the identity matrix, we have a series of ones in its diagonal, and other elements are equal to 0. That's what we call identity matrix. And when we talk about zero matrix, it means that all the elements should be 0. What about 0, 1? We have also this expression 0, 1. It means that it should contain elements zeros and ones. This term is also very important. Transpose of a matrix. What we do here? In this scenario, we are considering, for example, if this one has the size 2 by 3, 2 rows and 3 columns. When we talk about the transpose, we interchange the place of the column and row. So we will have here 3 by 2. You see, we are interchanging the position of row and column. So what's happening here? It means that if I consider the first row of my matrix, now I should consider it as first column. How do I show it? By this notation, transpose of the matrix. So for example, for the second row, I should write 4, 5, 6 as the second column of the transpose matrix. And this property is very important, especially in order to define symmetric matrix. So a square matrix A, what do we mean by a square matrix? It means that number of row and column should be the same, like 2 by 2 matrix. This is a square matrix, or 3 by 3. So when I can call a square matrix symmetric when the transpose of that matrix is equal to my original one. And as you can see, if I change the position of j and I, still the elements one by one, when I check it for I from 1 to n and j from 1 to n, they will give me exactly the same value. So in that case, we can define symmetric property in matrices. What about join and meet of A and B? So these two are very similar to the conjunction and disjunction that we talked about in the first chapter. So in order to find them, it's important for us to know that your matrix should contain binary numbers like 0, 1. So one of them can be described as false, the other one as true. So in that scenario, we can define join and meet of A and B. So the join of A and B is denoted by this disjunction. It means that element by element, you should calculate the disjunction of the elements. For the meet of A and B, we are considering it with conjunction. What about Boolean product of A and B? So it's not just a simple multiplication in matrices. Now we are talking about Boolean product of A and B, which is very useful for us in computer science, because most of the problems that we are trying to solve is related to, for example, the storage in our computers. Everything is stored in bits. So it is either 0 and 1. So it's very important for us to find the answer of our problems using such matrices and such operation in matrices, like Boolean product of A and B. In order to define it, we can define this like this. It's better I show you in one example so that you get the idea better. what you need to know is that we consider the elements of those matrices exactly the same way as we did in the simple multiplication, but instead of multiplying them, I use conjunction between them. And at the end, instead of summation, now I use disjunction. Let me show you an example. It will be much simpler to see that. Assume that I want to find Boolean product of A and B. In that case, when I wanted to multiply them like a simple product, I will consider these two together, right? As a simple product, it was 1 multiply 1 plus 0 multiply 0. But look at this. Instead of multiplication, now I have conjunction. Instead of summation, I will have disjunction. So you already know it from the first chapter. 1, 1. And the conjunction of 1 and 1, what does it mean? It means that it should be 1. So 1, disjunction. And what about this one? This is 0, this conjunction 0, which is 0. So what's the disjunction of that? 1 or 0. This is 1. So you already know it from the first chapter. So another example, like let's consider this one, for example. So conjunction of these two is 1. For these two, this is 0. So one of them, it should be, oh, sorry, I'm considering this one, right? So both of them should be 1 in order to receive 1. So it should be 0. This one also 0. So the disjunction of both of them together is 0. So be careful. Both of them should be 1 in order to receive 1. And we already talked about these things in chapter 1 anyway. So about algorithm, we already talked about it in the previous session. In the weekly assignment, you will see questions about matrices, not algorithm. But we need to know about algorithm because later you will see in the future chapters, I will give you some examples about the usage of discrete mathematics in computer science, and I will give you examples in terms of algorithm. So that's why it was important for us to talk about it, and it was in your syllabus anyway. Okay, guys, that was for today. If you have any questions, please let me know. Otherwise, I will see you on Wednesday. On Wednesday, we will talk about second assignment, and on next Friday, we will talk about induction as the new topic that we talk about next week. Okay, guys, if you have any questions, please let me know.